Hello, everyone. Welcome to yet another interesting Botcast episode powered by SmartBots. It has been more than 25 episodes that we have broadcasted so far, and we have got a really interesting response from all our viewers. And for the past 25 odd sessions, we have been talking a lot about the most promising topic on the globe today, which is generative AI, large language models, and RAG. We have brought in a lot of interesting speakers from industry, business leaders, and technocrats. And we've got a lot of interesting insights from all of them. And today's episode is really special for a reason. The reason is that I've been reading a lot of content on a medium, especially in the last 6 months, because things are changing on a daily and hourly basis. And in this the set of articles and blogs that I've been reading, I've come across one interesting article, which is 12 RAG pain points and the proposed solutions. And I thought, why not bring the author to our podcast and then have a detailed discussion, add value to our listeners. And guess what? I was successful in convincing the author of the blog to talk to us today. And here we go. We have Wenchi Glantz, who is the enterprise architect at Aris Global. Welcome, Wenchi. If you can introduce yourself, we can get going. And guys, this is JP. I'm your host, and I am accompanied by Onkar, who is my colleague, who will be the co-host. Once again, welcome, Wenchi. If you can introduce yourself, we can get going.
Yeah, thank you, JP. It's an honor to be here, and thanks for mentioning my blog. So I'm an enterprise architect with Aris Global, a life science company. So ever since ChatGPT came about, like everybody else, just so passionate and wanted to learn about this generative AI stack. So I started learning like other software engineers and architects, and since last May, discovered Llama Index, and from there onward, basically, it was each week I was assigning myself a task to do a deep dive, to do a POC, and learn about the framework, and then share with the community through blogging. So over the time, really the whole last year since May, and also continuing on this year, just really fascinating to see the framework blossom and expand, and to be able to handle production grade applications, RAG applications. So while the recent paper came out on the 7 failure points of the RAG system, so my first question is, yes, it's good to know the failure points, but what about solutions? So that triggered me to look into proposed solutions, mainly from a Llama Index perspective. So from there onward, I continued exploring and added 5 additional pain points. So I like to call them pain points because they're really not failure points, because we wanted to address them with proper solutions before they become failures in our system. So that's how this blog post came about, the 12 RAG pain points and proposed solutions, really to try to tackle the core challenges of a RAG system. So here we are. We wanted to explore together, and with your host JP and Onkar. So we're going to explore some of the core challenges together here.
Great. So, yeah, I'll just get going into this conversation today. And I see that most of the pain points, the answer looks like the right chunking strategy, right? And I also read somewhere in one of the articles that chunking is the mode for RAG. If you get your chunking right, then a lot of pain points would be addressed. So that's the high level idea I have about chunking strategy. I just want to hear from you and what you see as the shortcomings in each of these various strategies that you have for chunking, be it heuristic approach or be it using different techniques which are available out there in the market. What is your take on chunking as such?
Yeah, chunking is definitely, a key part of the retrieval portion of the RAG pipeline. So multiple techniques are, recommended, and really there's no one size fits all, in a way that we wanted to experiment with our, particular use case and figure out what is the best chunking strategy. So overall, there are a few, main strategies. Fixed size chunking, for example, you basically divide your text into, chunks of equal size word, like let's say 100 words or 200 words and so on. So obviously, the issue is that easy to see. You can break the sentences and concepts mid-flow, so causing the document structure gets kind of misinterpreted. So that's one major drawback of that. And there are other strategies like sentence-based chunking. So you basically, split your text at sentence boundaries. Llama Index has a particular advanced retrieval strategy called a sentence window node parser. So that is chunking on the sentence, and then you have a sliding window. You can define whether it's like a 3 nodes or 5 nodes. So before and after that particular sentence, you can have this sliding window so that all that context is then fed into your LLM for generation. Then also there are like a paragraph-based chunking. Obviously that is based on your paragraphs, and you wanted to divide chunk up based on your paragraph. So again, the issue with that is it's not perfect and might miss information inside the paragraphs that containing multiple topics. So, and there are additional ones you can even like chunking at the document-based level. So, all that is experimental, and concepts are there and for you to explore and experiment. So in this particular suggestion, the proposed solution, I did mention, the chunk size and the similarity top K. They're the so-called hyperparameters, some of the important hyperparameters. So the way through Llama Index framework that they have tuning strategy, it's called a prompt tuner. So using a prompt tuner to be able to, we can provide an array of, different chunk sizes, and also the top K is a number for the top K. Then the system can go through a matrix of matching the different chunk size with different similarity top K, and run evaluation in the background. And then the output is that it will be able to give you the list of the evaluation scores for each combination. Let's say if I have a chunk size 512 and 256 and also 1024, and top K would be 1, 2, 5, and so on. So the combination, the matrix combination of that would give the output, and each one will have an associated score. So by looking at the score, you will know for your particular documents or use cases, you will find the top scored combination. So you know that that particular chunk size and that particular similarity top K would be the best combination for your use case. So that is the proposed solution there.
Just a small doubt here, but how it will be generalized, the chunk size and similarity top K, because different document will have different structure. And so by doing the hyperparameter tuning, we need different chunk size and similarity top K for different documents. So problem here isn't it the hyper generalizability is the problem here? How to generalize?
Well, yeah, so I would say for a particular POC, when you try to determine the chunk size or similarity top K, you wanted to have a combination of your typical documents, the structure and so on. You can have multiple documents and select as your POC documents to do the initial selection, and then run through the evaluation and the prompt tuner, and you will find the best combination, because there is no one size fits all. So we have to find the kind of, the balance act between the different types of documents, the different chunk size, and the different similarity top K. So that is the best strategy so far we can come up with. But, obviously let me know if you have better suggestions. I would be happy to hear.
So one question I have regarding, you have mentioned the topic of chunk, right? So is it a fair assumption to say that the chunk should have a cohesive nature in terms of like one chunk should talk about one topic? Say if I make a chunk which has say advantages as well as disadvantages in the same chunk, do you see that the effect of that chunk is getting utilized because you're talking both positives and negatives in the same chunk? So getting to the chunk would be a challenge. So do you see that to be a right way while we are designing the chunking strategy?
I think this is would be, my take is the document itself in a way, if it's a well-structured document, right? So document paragraph-wise, if one paragraph talks about its benefits and the next paragraph talks about the disadvantage. So right there, it could be, immediately can think of probably paragraph-based chunking would be the best strategy. But if your document has a mixture, they're totally mixed together in one paragraph, then really I think, using the fixed size chunking would be applicable, because, in that type of scenario, even sentence-based chunking could be applied by using the sliding window. So to try to capture the best context possible during retrieval. So again, it's, dependent on your document structure and how this chunking can be applied.
So you mean getting to the cohesive topic or cohesive chunk should be our goal. In the case when the documents are well structured, then it would be paragraph wise. If not, we'll have to do a heuristic way of trying out multiple chunking strategies. But fundamentally, each chunk should speak about one topic, and yeah, how we get to the right chunk.
That would be definitely idea. Each chunk talking about a specific one topic, but in reality, documents are not like cannot make that kind of perfect scenario. That would be awesome to go, but right.
Right, right. And also the size of the chunk. So I keep hearing the size is another important factor. See, you can have a one page chunk or a one sentence chunk, right? And I also see the merits and demerits of each of this. So what is your take on the size of chunk size?
That's what I just mentioned. You have to use a prompt tuner to fine tune. I mean, to really decide tune the hyperparameters and figure out what is the perfect chunk size and the combination with top K. So use the tool available, in the framework.
So we should use different type of document in prompt tuner and do the hyperparameter tuning to get the optimum chunk size and case score, isn't it?
Yeah, I would suggest you pick the typical, like if you have multiple types of documents, pick them and then, evaluate with prompt tuner and to find out the balancing chunk size and top K.
And talking about the evaluation, how do we do the evaluation for this kind of a use case?
Yeah, so evaluation in this kind of use case is will focus on the retrieval. So in Llama Index, there's a evaluation framework. They have a module of multiple types of evaluation, whether to evaluate from end to end or just on the retrieval side, faithfulness, similarity, relevancy, correctness, and so on. So it's very much similar to the Ragas framework. So the concept is very similar. So this prompt tuner behind the scene, it uses this evaluation strategy to figure out the best combination of the chunk size and similarity top K.
Got it. So what I understand is like hyperparameter tuning and using Llama index for evaluation at retriever level or at the overall level is what we need to go as the right strategy, iterate and then get to the right set of hyperparameters. Did I summarize it?
Yes, that is recommended. Yeah.
So Venki, just a small doubt for getting the accuracy metrics for, do we need to create our own dataset, supervised dataset for getting the accuracy for RAG? Can you tell something?
Yes, evaluation you definitely wanted to have a golden data set. So the way to create a data set, obviously you can utilize LLM to auto-generate your data set for you. And then you can manually edit and modify or add additional questions or delete, whatever is LLM generated question which didn't make sense. So try to come up with a golden data set that use that same set to evaluate different combinations of whatever you're trying to evaluate, whether it's a retrieval strategy or whether it's even, evaluating LLMs or embedding models. So then with that golden set, you can compare apples to apples and figure out what is the best, whether it's strategy or LLM or embedding model and so on for your RAG pipeline.
Okay, thanks. Yeah.
Yeah. So moving on, this is reference to the point on missing content or the document is missing, or I call it the false positive case. This is pain point one in the blog. And I see that your answer to that or the proposed solution for handling missing content is cleaning up the data. So let me give the context for the audience here. So when the set of documents don't have the answer, there are cases where your RAG solution might give out an answer based on the information which it is able to map to, right? So that's the use case I'm talking about, and this is the false positive cases. My question to you, Venchi, is the false positive cases. The answer that you've proposed is data cleaning. Do you think that data cleaning alone will be sufficient? Because I feel that again, chunking, as I said, is the answer for many of the pain points. We should focus more on chunking than data cleaning, was my viewpoint. I wanted to understand.
Sure, sure. Yeah, the first point really talked about missing content. What does that mean is the content, it doesn't even exist in your document. So the point we're trying to address here is LLM actually generates a kind of hallucinated answer that appears to be confident, appears to be the correct answer, and unless we go back to validate the document and realizing, oh, that is not even talked about in the document. So right here is two proposed solution. Clean data is one, and then the better prompting is the other. So on the clean data end, the reason why it's important is because the quality of your document matters, right? So if you have document, also one of the problem with if you see this particular pain point, one of the reason also you could have conflicting information in your document. So in one paragraph you might say, oh, this benefits is so and so, but in the other paragraph you may talk about the same thing but as a disadvantage, for example. So that is confusing to the retriever to try to figure out what is the actual real answer. So the clean data portion of the proposal is to focus on trying to get your data clean, because in data science we all understand the importance of quality of the data, clean data, garbage in, garbage out, and we cannot produce good content out of garbage. So that is one aspect that we have to be sure when we build our RAG pipeline, and how good our data is, and it obviously cannot be perfect, but if you have the documents that contain conflicting information and so on, or bloated, or so those type of stuff, we wanted to try to clean them up. And then the better prompting portion is also very important. Oh, by the way, just to go back to the first point with regards to clean data, so was trying to look online to see if there are any particular strategy or one size fits all kind of solution to clean data. It's hard to find. So I did not find any, except unstructured.io has a set of libraries cleaning functionalities. Yeah, I would recommend you take a look, and most likely if you can use that, that would be awesome. Then better prompting portion is, try to instruct the LM, to tell me if you don't know, if you're not sure of the answer. So I feel that is sort of the best effort that we can try to instruct the to just say I don't know. So that is the point.
So we can reduce the hallucinations in case of missing content by better prompting, I think. Yeah. So requesting LM to tell us that they are not sure of answer if they don't know.
Yeah.
Is that a right way to understand that one data cleaning will help in at the retrieval stage, and the prompts would help at the final stage of RAG pipeline? Is that the right way to understand this?
Yes, I would say yes, but they work hand in hand. So I would say both are important to ensure that we get the response we want. But again, we can only instruct. There's no way to guarantee 100% accuracy. So this again, it's a proposed solution and worth a try.
Sure. Moving on to the next topic is about the data type, the types of data that the document is holding. And most of the time, when I interact with enterprises, they have a lot of data in like financial documents or legal documents. So there are different types of data which enterprises deal with. Primarily the tables. If you take tables as an example, and when we deal with RAG kind of a solution where there are a bunch of tables, let us take a financial statement of an organization. How can RAG help in dealing with data in tables?
Yes, good question. So this one, Llama Index also offers an advanced query strategy. So that allows us to be able to query the tables inside PDF documents. So it's a two-step process. First, to convert the PDF into HTML. So in my blog, I did mention that, and it's one of the advanced query strategies. You can retrieve the data in the table by calling that particular Llama pack that to retrieve the embedded table inside the documents. And so I did a POC on that, and I was able to see successfully. I was able to pull the data from the table in a PDF financial document. So check out my blog for detailed instruction.
To Venki, just small doubt. In case of financial statement, like let's say name of the equity holder and something like that, that they can be written in different tables. So do we need separate type of embedding, or want it mixed different chunks will mix with different another chunk for our tabular data answer?
Well, the passing of the table data is handled separately. So you have your, the content outside the table that's going through the normal chunking and all that. But the inside the table through the HTML processing, it is doing hierarchical retrieval to retrieve the data within your table. So that is not handled the same way as your regular content outside the table.
So one small dot, using tables metadata into as a filter, will it help? Like tables metadata, or let's say tables heading, if we are putting all these metadata into our chunks, and when we are asking question, then filtering those metadata, will it help?
Metadata definitely helps with more accurate retrieval. That is, we looked into that. I even blogged about and did the POC on that as well. And adding metadata to assist in the retrieval is definitely a good strategy. So would highly recommend that you apply that to. You can observe the before and after, check out the difference. So I would say in such scenarios, you can do a combination metadata plus embedded table retriever and all any other advanced query strategies. So do feel free to have a combination of that and test it out.
Yeah, once another question is that, using, since generally we use OpenAI embedding for creating embeddings, so should we fine tune our embedding for different type of, like you are working in life science, they will have different data. So OpenAI embedding is a generalized embedding model, so it doesn't work in different all scenario. So many times we fail. Like in our case, we are a conversational AI company, so lot of cases it fails, it just mixes with different type of data. So for that, you have mentioned that we should fine tune using llama index, so how much that helps?
Yes, absolutely. I think the conclusion on the fine tuning was, I believe, was around 5% or so. So absolutely recommend fine tuning your embedding. But OpenAI's embedding, obviously, they don't have that option for us to fine tune it. But I would highly recommend go to MTab leaderboard and find open source embedding models. So right now, OpenAI's embedding model is not really on the top of the chart there anyway. So find some open source embedding models and fine tune it. And Llama Index has detailed instruction on doing that in the proposed solution. So feel free to look at the sample notebook and follow the steps to fine tune the embedding model. And you can also compare before and after.
I was looking into that, but your blog mentions about fine tuning GPT 3.5 turbo, so that embedding won't using sentence transformer.
That is for the LLM. So that's fine tuning LLM is a different solution. But for the embedding model, definitely you can fine tune your embedding model. But it's fine tuning open source embedding model, not OpenAI's.
Okay. So that brings to the middle of our conversation, and so we are planning to have this in two episodes. So we are at the end of the first episode, and we'll see again in the second episode, which will continue talking about the same topic, the 12 RAG pain points, and see you guys in the next episode.